Hello and welcome everyone to this speak. This speak is from Texas to Insights, empowering NLP models for document question answering with generative AI. My name is Carlos Rodríguez Avellan, based here in Madrid, Spain, and I work as a lead NLP natural language processing engineer in the Center of Excellence of Data Intelligence in Fujitsu. So basically, I'm working creating natural language models for several industries in different geographies, creating these semantic capabilities to solve real problems now for different tasks about this natural language processing environment. So starting with the talk, with the speak, today I will be talking about some of the most recent advances in generative artificial intelligence, generative AI, and also how these models, these large language models, have revolutionated the different sectors, different domains, not only for natural language processing, also for computer vision task, artificial vision task. So these are the main topics in nowadays. So one of the main tasks in natural language processing, also in computer vision, is document question answering. We will take a look later to this specific task, but basically, document question answering task is the process that in which we can ask questions to documents and try to get relevant information, relevant content from these documents. The idea is that the models, in that case, the large language models, answer us using human-like natural language. Okay. So today, during this presentation, we will explore how generative AI and large language models can help us when creating these natural language queries, when working not only with a single document, but also with large-scale corpus. And the idea that represents all these concepts is the technology, a technique of retrieval augmented generation. So starting from the very beginning, when we talk about large language models, I will not introduce what large language models are. I am aware that all of us are know what they are. They solve a lot of different problems. They are the state of the art of, let's say, artificial intelligence models for natural language processing. And when we talk about main players in the ecosystem, of course, OpenAI is a company that comes to come to us, to our mind, because they plays a pivotal role when shaping the landscape of generative AI, of course, not only for natural language processing, also when we talk about speech to text processing, and also with computer vision, we can talk about, that, for example, DALI 2. So starting in 2018, they deliver or they release this architecture called GPT. Nowadays it's GPT-1, the first model, this generative decoder only, architecture decoder only model. So if we take a look to this evolution of GPT series models, we can see that they have included more complexity into the model architecture. They have included, for example, instruction tuning. For example, they have included also code, so Python, Java, other programming languages into the data sets. So the large language models are able not only to generate human text or human language, but also programmatic language, like, for example, function or classes in Python language. Okay. Nowadays, all everyone is talking about generative AI, probably thanks to OpenAI when they released ChatGPT last year in October 2022. And nowadays with GPT-4, that is also a multimodal model that works not only with text as input, but also with images, these models are more and more complex. The reality is that not only, of course, not only OpenAI is creating and releasing these kind of models, multiple companies, like for example Google, like for example Meta, like for example Alibaba, for example, people from Zalando, from a lot of different companies are releasing different models, also from universities, also from actually individuals are uploading models to the open source ecosystem, most of them publicly available on Hugging Face models. Also, not only models, but also data sets to train and to evaluate different large language models. Okay, so if we take a look to the right image, to the right picture, we can see the huge amount of different big large language models. And I say big because all these large language models contain more 10 billion parameters. So they have a huge number of parameters. Okay. And also, we can see how different models from OpenAI, like GPT-3, like for example GPT-4, released from the people of OpenAI, are present, but also models from Meta that plays a critical role in the generative AI ecosystem, publishing or releasing models that are open source. The most famous and the most popular nowadays is Llama 2 because its performance solving any kind of NLP task, classification, topic model, summarization, translation, and so on. Okay. Of course, different models are trained with different data that can come, for example, from web pages, from conversational data, from books, news, or maybe from code. Okay. And also the community is talking a lot, is creating a lot of, there is a lot of hype around LLMs, around generative AI. Actually, we take a look to the cumulative number of scientific papers published in the archive platform, we can see that the number of papers that talk about language models or large language models are increasing exponentially over time. Okay, so it is a huge moment for these technologies. Actually, when we want to select a large language model, of course, as I mentioned before, there are a lot of different large language models. If we go to Hugging Face, we will see that the number of different large language models is huge, and actually it changes every day. So I have included here a screenshot of the results of the top tier performance models. In that case, I am talking about Open Large Language Model, and this is the Open Large Language Model leaderboard from Hugging Face. This is a disclaimer, results taken this week, first week of September 2023. So we can see that that most of these models are Llama 2 based, Llama 2 architecture based models. So for example, the first one, the 3.1 and so on, takes Llama 2 as the base model for as a fine-tuned version or instructed tuned version from Llama 2. So Llama 2 nowadays is playing a very important role in the LLMs, in that case, Open LLMs ecosystem. So this is like a very, very fast introduction about maybe not large language models, but about the rise of these kind of models, about this kind of technology. Let's focus on the topic of today's speak, that is document question answering in large scale corpora. So when we talk about document question answering, we are referring to the task of answering questions using information extracted from documents or specific pieces of text. So if, for example, we have this Wikipedia article that is talking about Rafael Nadal, a Spanish tennis player, if we have a model, like for example, Llama 2, or if we have a model like, for example, ChatGPT, we can try to, and if we want to know information about Rafael Nadal, we have two ways. Well, we have different ways, but we have like two ways. The first one is, okay, I have access to ChatGPT or I have access to a model like Llama 2, and I say, okay, Llama 2, I want to know how many Grand Slams has Rafael Nadal won in his career. The model, Llama 2, ChatGPT, whatever model, since they have been trained in very large data sets, probably they have the knowledge about who is Rafael Nadal, and probably they will have the knowledge, about how many Grand Slams has Rafael Nadal won. The thing is that what happens if we want to answer specific information about very domain specific content or information to the model, then maybe the model is not aware about the content. So the thing is that, okay, I have a document where appears the information, because I'm very sure that the information about Rafael Nadal appears, of course, in the Wikipedia article about Rafael Nadal. and I also create a query that talks about the question, okay, that I want to ask to the model. That is, okay, how many Grand Slams has Rafael Nadal won in his style career? So these two pieces, the document, the information, and the query itself, is the input of the large language model, a generative model that responds me that in that case, Rafael Nadal has won 22 Grand Slams. So this is the like very brief summary about what document question answering is. The thing is that if we want to create a complete pipeline of document question answering, we need to create a pipeline composed by the next steps that basically starts from the very beginning in the data preparation, data collection and data preparation. When we extract the content, we extract the text, we extract the tables, we extract the images from the different documents, where we are identifying relevant sections into the document and maybe segmenting the document into different pieces of text, into different chunks. And then maybe we want to index this information into a specific database. We will see in a minute. Okay, so we want to store the information, sorry, we want to store the information of different documents into a specific database in order to go then later in order to in order to retrieve the information. So the idea is to, if we have several documents, like for example, several Wikipedia articles, we want to, we will process this information, we will store this information, and then the idea is that we will make queries to this database, and a specific model, a large language model, will answer us in human-like language. So let's take a look to some of these steps, to most of the most relevant steps here. One of them is the layout parsing, because when we work with different documents, these documents maybe are image-based, but sometimes are text-based. So the thing here is, okay, sometimes we are working with very simple documents, a narrative, single column documents, no images, no tables, no figures, anything else apart from text. But the reality is that when we work with documents, we can expect almost everything. So here we have an example in the picture, in the right picture, where we have a single page from a scientific paper, where in a single page appears a figure composed by different screenshots from different pages, where we have a paragraph in a single column, and then we have two columns with different paragraphs, with titles, subtitles, and we also have here a table with tabular data. So the thing here is that we need to, is very powerful, is very recommendable if we include a step when extracting information from the documents, if we include a step of layout parsing. And in order to do that, the people from Layout Parser, that is the name of the framework that I am presenting here, the layout parser technology, the layout parser framework, contains several deep learning models for automatic detection of the structure that is underneath the different documents. So for example, in order to detect where a figure appears and actually say, okay, this section, this region of the document is actually a figure, this region of the document is actually a table, this one is a paragraph, and then filter or not this content according to our needs. So this is very, very relevant and very, very useful, because we can preserve document structure and we can delineate relevant regions. So basically what it is useful for us or for our use case, and what regions or what content it is not useful, is useless for our use case. So extract only relevant document from extract only relevant content from documents, filtering the rest. Okay, so here I am including, during all the presentation, I'm including the references to the frameworks, to the papers, and so on. Here we can find on the bottom the reference to this framework, to Layer Parser framework, open source framework. Okay. Okay, next step. So when we talk about how we can index the information into a database, into a knowledge base, a very, 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 very important step here is the embeddings models. And this is not new. The embeddings models basically is a way to represent information, not only documents, but for example, a user in an e-commerce portal, or for example, an image or a video or an audio, whatever information, type of information that we can imagine. An embedding is a numeric representation of different features or a specific object from the reality. When we talk about natural language processing, an embedding model refers to the model that is able to calculate a numeric representation, a vector that basically is a numeric a sequence of numbers representing specific features about this document. Maybe these features are referred to lexical information, that is, okay, what words appears or not in the document, but more recent embeddings from actually from Word2Vec, these vectors, these embeddings contain also semantic information. And this semantic information, if it is stored in the numeric representation, in the document embedding, is a very powerful tool when we want to compare two different vectors, two different documents, because we can compare not only the words that they share, but also the semantic, if they are talking about the same or not. When we talk about frameworks, when we talk about models, here I have included three of the most popular and with better performance embedding models for natural language processing. Actually, these are large language models, which main task is for document embedding. So the first one is from OpenAI, that is the popular ADA text embedding model. But if we go to open source technologies or open source alternatives, we can talk about E5, that is embeddings from directional encoder representations from Microsoft, or Instructor from the University of Hong Kong. All these links appears below in the slide. So instructor model is a very interesting technique, or a very interesting model, better said, because we can calculate not only the embedding for a specific test, but also we can say to the model, we can include into the prompt information about the main task that we want to cover lately when we get the embedding from the document. So for example, here we have a screenshot extracted from the paper, from the publication, where when we calculate the embeddings for different documents, for different text, we say to the model also what we want to do with these embeddings. So for example, I want to calculate this embedding for text classification and take into account that this document comes from a financial report, for example. Okay, so embedding models plays a crucial role when indexing information as a vector or as a numeric representations. Okay, the same way than as we did with the large language models, if we go to Hugging Face and take a look to the massive text embedding benchmark leaderboard in Hugging Face, we can see the top tier performance embedding models. Actually, if we take a look to the results, or if we take a look to the top models, and again, and that's a disclaimer, of course, for the future, these results are taken in the first week of September 2023, so probably results in the future may change. But if we take a look here, nowadays, the embeddings models, and not only appears open source embedding models, appears in general also any word embeddings or document embeddings models. For example, number 13 is the ADA model from OpenAI. Here we can find that E5 instructor or ADA appears as a top tier embeddings performance. I have to add a mention here, and is that these metrics have been calculated just for English language. The thing is that embedding models, depending on the language, as any other natural language processing models, maybe work better or maybe work worse. The reality is that mainly most of the resources on the internet, publicly available and not publicly available, are created for English. So the reality is that for other languages, like for example Spanish or French or German, there are less resources, and the resources that appear, or there are, maybe have less performance. So this is a very a very topic to take into account when we select a model, and depending basically the language in which we are working. Okay. So let's continue with the next most or main important concept, and this is the information retrieval. And this is basically the last concept that I will present before going to retrieval augmented generation. Information retrieval, that basically consists on two steps, indexing and retrieval. It is a concept that it is not new. Actually, it's from some decades ago. Basically, it's the way in which we store information. In that case, we are using embeddings, we are using vectors in order to store the information, as we mentioned before. And the second step is the retrieval, as we mentioned before when we were talking about document question answering. That is, okay, I have a query, I have a necessity, an information need, and I want to solve this information need, querying the database, querying the knowledge base, and getting a response in a semantic search. Okay. The thing here is that what happens if we combine classical information retrieval systems with generative large language models. Okay. The thing is that, okay, we can think we have a model like, for example, Llama 2, and we have a lot of internal documentation in a specific company. And we say, okay, this model, Llama 2 or ChatGPT or whatever, Llama 2 is very good solving all the natural language processing tasks. But I want Llama 2 to be working with my own data. Okay. And I want to maybe retrain the model or to access to different information. How we can do that? How we can deal with very specific data with very domain specific tasks? Well, the thing is that large language models have some limitations here. The first one is that they are not always up to date, because when they have been trained, for example, GPT 3.5, the version of free available or public, well, free available, free accessible ChatGPT version, contain data until a specific date. After this date, this model has no knowledge, so it's not up to date. And this problem, this limitation, happens to all the large language models. So if we today train a model with very with data from today, in 6 months, the knowledge of this large language model will be out of date. So this is one of the limitations. The second limitation is common to all deep learning technologies or deep learning models, and is that they work as a black box. It is the interpretability of these models is not easy. So it's very challenging to understand their predictions, why they predict what they predict, and how we can alter the results. Okay. Actually, and this is the third point, maybe sometimes they tend to hallucinate. And basically it is that they return information that is plausible, but with fake information, with false information. Okay. For example, when I ask in the example before, I say, how many Grand Slams has Rafael Nadal won? Maybe the model say that Rafael Nadal has won 2,000 Grand Slams. That, of course, is not real, but the response has good structure and is correct grammatically, and so on. Okay. And then, as I mentioned before, large language models are not good enough when working with domain-specific tasks. So here we can think in two ways when working with or in order to refer to specific data. The first one is fine-tuning. Okay, I have a large language model like Llama 2, and I have my own data. Let's fine-tune the model. And actually, that's a very good option. And actually, it solves a lot of problems when working with in specific tasks. But the thing is that we will have the same limitation in the future, because we will need to retrain the model in order to make it up to date. The second one, and of course they are compatible between them, so we can use prompt engineering with a fine-tuned model, of course. The second one is prompt engineering. That is, let's give to the model, when accessing the model in the prompt, let's give to the model some context. So let's give some examples. Let's give to the model some specific information, some specific data, And that's true that nowadays the LLMs contains bigger and bigger context windows, but this context size is limited. So it's a very this is an important limitation. Okay, so if we want to work with a huge amount of data and we want to access to this amount of data with large language models, what we need to do is to go through retrieval augmented generation. Retrieval augmented generation is the main topic of this speak and is the technology, well, modern technology, the technique that groups all the concepts that I mentioned before. It was proposed in a paper by the team of Meta Research in 2020. So it's not very new, but it is new in terms that nowadays the large language models are more powerful than before. So we have good embedding models, we have good large language models, and we have the information retrieval architecture since 1970. So this is a perfect momentum for natural language processing tasks when working with large volume corpora. So basically, retrieval augmented generation combines, as I mentioned before, the strengths of retrieval and indexing, of course, working with embedding models, and the generative AI when solving questions. So the idea here is that, okay, let's index the information as I mentioned before in the information retrieval slide. So use an embedding model to process documents or chunks of the documents into a vector space, into a vector database. Then I can access to this information querying with the query embedding, using of course the same embedding model that I use it for creating the database. Compare the vector, the embedding vector of the query with all the existing all the stored embeddings and get the most relevant results. And here the idea is, okay, I will not return these relevant vectors or relevant documents or relevant pieces of text to the user. No. This relevant information plus the prompt with instruction and plus the query with my question will be the input of a generative large language model that will that basically will generate the answer about that specific part of text of that specific information that I have retrieved from the my knowledge base. Okay, I will give an example. This example is from the people of Cohere. I published it, I think, in April of this year, 2023. Basically, with their multilingual embedding model, they have processed Wikipedia. Well, not all Wikipedia, not the entire Wikipedia, but a lot of different passages from Wikipedia. So they have selected millions of Wikipedia articles. They have segmented every Wikipedia article into passages, and for each Wikipedia, for every passage, they have computed the embedding. So we can see the result in the table at right, and this table is available in Hugging Face datasets. We can see how for each article passage, they have calculated a specific embedding. So they have published this knowledge base about Wikipedia content. Okay, of course it can be used for, okay, let's do some queries like the query that I presented at the beginning of the talk, at the beginning of the speak. Okay, how many Grand Slams has Rafael Nadal won? I calculate the embedding, compute the text similarity according to a specific metric like, I don't know, cosine similarity with all the already stored embeddings, get the relevant content, in this case, Rafael Nadal Wikipedia article, or maybe some of the passages about this article, and generate the response with a large language model, like, for example, Llama 2. Okay. Other examples is if we work with scientific papers, working with the platform archive, or for example, with PubMed, with papers from the healthcare sector or from technology or whatever topic. And we want to be up to date about the latest scientific publications, making indexing all the information in an automatically way and accessing the information in a natural language manner. So we can access information in a natural language way. and it improves a lot the way in which we interact with technology. It improves a lot in the way in which we interact with the information. Okay, and of course it can be general. So if we have a module that calculates the embedding from specific documents, and we have a specific large language model like Llama 2, we can create pipelines to process information in any domain for any task, like for example, internal documents for specific companies. Okay, and this is a very interesting because we don't need to retrain a model, and actually we don't need to retrain a model and to publish or to share this model to other people. No. The only thing that we need is to store the information, keep up to date this information, and prepare nice pipelines in order to process the documents and in order to calculate the embeddings of this information. So if we have good pre-processing steps or pre-processing pipelines, if we have good embedding models, as we do, and we have good large language models, generative large language models, and we do, these pipelines, the creation of with these pipelines is possible. Okay. So as a conclusion, the idea here is that we can combine the powerful of as I mentioned before, of the information retrieval architecture with embeddings, models, and large and generative LLMs. So this is a very big step forward in making the most of these LLMs, basically with these three main things: enhanced information retrieval. So retrieval augmented generation allows for more effective and context-aware information retrieval from vast corpus, from vast data sets. It enables precise responses to user queries, human-like responses. Okay. Also, the importance of contextual content generation. So it empowers the generation of contextually relevant and coherent content. So it can improve, and actually it improves the quality of the generated responses. And also the versatile application. So we can include these techniques in different applications, not only chatbots, of course, is very useful for chatbots, but also for internal information retrieval systems, or for simple or for more complex with less data or more data, expanding the utility of large language models with very domain specific information. Everything, of course, we have talked here about the state of the art publicly available models, like, for example, E5 for embeddings, Llama 2 as generative LLM, that they are not only accessible, but also represent the cutting edge AI capabilities. Okay. Thank you very much for your time, for listening, for have me presented here during this presentation. Of course, if you want to connect or to talk, to chat, don't hesitate in to reach out via LinkedIn. Okay. Thank you very much to all of you.